Hey Rickies, welcome back to BiharGeeks. So today we are going to solve a very interesting problem that is based on linked list. The problem is the linked list cycle. Okay, so we have given a head, and the head of a linked list determine if the linked list has a cycle in it. And there is a cycle in the linked list if there is some node in the list that is reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tail's next pointer is connected to. Note that position is not passed as a parameter. Return true if there is a cycle, otherwise we have to return the false. So in this example, we are given a list, okay, 3, 2, 0, and minus 4, and the position is 1, 0, 1. So this is the position. So as you see, whenever we are going from 3 to whenever we are like iterating 3 to 0, 4, and again we are moving to this position. So this position is again seen by twice time, or it continuously, it's like a never ending. We are just moving this way, okay. So we never reach to the null case. Okay, whenever in the linked list, whenever we iterate and we get a null thing, so we get to know that we are at the end of the linked list. But here, this is not a condition. Same for this condition, there is a loop at the zeroth, and if we see that the condition is true, it's like endless only. But for this case, the position is minus 1. So here, there is no endless flow is there. So that's why it's just returning a false. Okay, so there is no cycle for this last case. Otherwise, there is a cycle for both the cases we have seen. So we are going to basically solve this problem using two approaches. First will be the two pointer, and second we will use with the hash set. Okay, so let me start with the first approach, that is we use the two pointer approach here. Okay, and for this case, if we talk about the time complexity, it will be O of n only. And okay, and for the space complexity, for this case, as we are using only constant case, so it will be of O of 1 only. Okay, so let's start with the first base case. If we have given a head only here, okay, if head is already null, or our head next is also null, okay, in that case we just simply return false, right? Otherwise we have to iterate, and before iterate we need two pointers. First we will name it as head, and like we are putting a we are putting us one step slower and one step faster. So in that case, we will put one as a slow, and we put a pointer with the head. And same, we have to do it for the fast ones. So mm, fast, and also inside that we are putting a pointer of head. Now we have to put a loop till the value is not equal to null. Okay, and same for we have to do it for the fast next. The next is not equal to null. Fine. Inside that we will move slowly one step. With slowly we will move one step, and with the fast we will move the two steps. Okay. So slow will equal to slow dot next, and with fast, as I told you, the double step, that will be fast dot next dot next. Fine. Now inside this we have to put a condition. If slow is equal to fast, so in that case we got the cycle detect. We basically detect the cycle here. So we just simply return the true from here. Okay. And if we get out of this loop, it means that we didn't get any loop from here. So we just simply return false from here. And we have used the approach that is called the two pointer. Okay. So I'm running this. We are getting at line number. Okay. And we can do run this again. Okay, it's got accepted. Let me submit this now. So this is done now. So we have used the concept of two pointer here, and we have two pointers here. Okay, and we are iterating using fast and slow will be like there will be increment of single step, and for the fast we will have a double increment. And then we are checking that if both values are same, so we just simply return the true because we detected the cycle is present here. Otherwise we just simply return the false. So this is a way of doing with the two pointer. And we already talked about the time complexity. For this, the time complexity is of n only. Okay. Now there is a second approach, that is we will use with uh, the hash set. Okay. So for the hash set approach, first we need a set here, and putting the type this node, and we will keep the name as visited, right? And I'm keeping it as set. Okay, this is done now. After this, we have to need a head only here. Okay, so I'm putting current because we have to iterate. So I'm putting a pointer of head inside it. Now we have to iterate. So till the current node is not equal to null, we will iterate. Right? Now, if are visited, which we have created here, it's already present. Okay, dot contains with the current node. So in that case, we got the cycle. We just return true from here. Okay. Otherwise, what we have to do, we just need to iterate. So we'll keep visited dot add current inside it. Okay. And secondly, what we have to do, we have to just simply increment. So current will be equal to current dot next. Fine. Okay. So this is done now. And one thing we forgot, we have to put if nothing is found, we just simply return the false from here. Fine. It's got accepted. Okay, it's got accepted also here and submitted. So the thing is difference between that the two pointer and this HashSet thing, that the time complexity for both the cases is off and only. The difference with the space complexity. For the two pointer there is a like a time complexity of off one only. But for this case, as we are using the space, so the space complexity is of n only, because as like if we have a value of like 5, so it will like storing the value of 5 only. Okay, because we are like adding things also here. So for that case the space complexity is like higher than that they proof that we previously used, that is 2 pointer. In that case the space complexity is like little come like it's like of 1 only in that case. Okay, so that's it for today. Hope you like this video. Thank you for watching. Bye bye.